All right. Y'all want me to start the stream. Where are we? I see two people in chat already. I got Kelvin and Nerd Garage. Hello. Hey, everybody. Smitty here. I can't tell if that's too loud on the mic. It does look like I'm peeking out in the red. Sorry about that. Smitty here. I'm going to be doing some live KiCad work today. I am kind of one of the lead folks. Audio is good. Thank you, Nerd Garage. See, just as I was about to go do supper. Yeah, it's my job to keep you thin and healthy, right? Anyway, so I'm kind of one of I am the lead person at this point on the Open Headset Interconnect standard, and I was chatting with the folks at the M17 project, and they are going to add an OHIS port on the Module 17 board. And when we were discussing that, they asked, are there any open source, or is OHIS open source? And I had to clarify, like, well, OHIS is a license. The license is open. There's no restrictions on the license. I want everyone to use it. But the only hardware being produced so far are my commercial products, Halibut Electronics. And they kind of accepted that. And I realized that it would probably be a good idea for there... Yeah, I am clipping out. It would probably be a good idea for there to be an open source schematic out there for people to use to get started with their stuff. So I am... Hey, Steve. Anyway, I am going to design a open source version of a user adapter today. I do sell a user adapter with Halibut Electronics. My user adapter is considered a pro model adapter. It has lots of spiffy features, and it comes in a spiffy case. It's also kind of expensive. So I am going to do an open source version without some of the spiffier features, and it's just going to be pretty stripped down and basic, but it'll get the job done for the vast majority of people. So I think that is probably the right way to go. I will also probably end up selling this open source version for people who don't want to go out and make their own boards. They can just throw money at me and I'll sell them one open source, or you can take the design and go build your own, or you can take the design and use it as a starting point for your own design if you wanted to make changes to it and whatever else. If you are a company and want to compete with me, please do. If you're a company and want to use this design, there is not a non-commercial tag on the license for this, so you are welcome to use this design and start selling your own, or use it as the basis of further work that you do and add your own special features to it and make a commercial product out of it. So my goal is really to get as many people to use this as humanly possible. Yes, even if that means that you're competing with my company. So that's okay. So this here is a blank KiCad sheet, right? There's nothing on it. The source for this is going to be up on GitHub. I don't know what's in my browser, so I'm not going to bring it up right now. But, oh, that's not true. I have it right here. So let me just bring this tab down. The source for this is going to be on GitHub. It's in the Open Headset Interconnect Standard repository. No, user. Open Headset Interconnect Standard Working Group is the name of the user, and then there is a repository called User Adapter that I just created. And it's going to be KiCad, and it's the Creative Commons by license 4.0. Otherwise, there are no files in it right now. So I literally just... No, don't do that. Do that. There we go. Thank you. I literally just created a new KiCad project, and that's all I have done. And then I said, I really ought to be live streaming this. So that's what I am here doing. All right, let me bring the live stream back up there. Okay, cool. We got some people watching. So one thing I do need to do is share some of the custom libraries that I have made for in my own thing. I need to move some of these into an OHIS specific KiCad library and share them. But I've created an outline that is just an RJ45 connector, but instead of just the pin numbers there, it actually has the OHIS signal names on it. Makes it a little easier to understand your schematic. I've got one with LEDs and one without LEDs. On this one, I think I'm going to go without LEDs. And let's go plop that down on the schematic somewhere. The other connector I know I'm going to need is a couple of audio jacks, and I want at least one of them to be a TRRS, a 4-pin audio jack. So rather than have multiple connectors on the bill of materials, I am going to make all of them TRRS 4-pin jacks, even though I only need 3 on one of them and 2 on the other one. So let's go headphones, and we'll duplicate that down here. We'll make this microphone, and then another one down here, value PTT. Okay, so I've got my 3.5 millimeter sockets over here for headphones, microphone, and PTT. I'm going to make it so that the headphones connector is configurable to be a CTIA, 4-pin headphone left, headphone right, ground, and microphone on the shield pin. That's why I want that one to be a 4-pin. This one only needs to be a 3-pin, and this one only needs to be a 2-pin. But rather than have 3 different items in the bill of materials, these connectors are super cheap. I would rather just have one item on the bill of materials and use 3 of them, even if they've got more pins than what you need. So, while we're doing this, let's go through and pick some outlines. I am going to design this as through hole, even though I prefer surface mount. But if I'm going to make this something that other people build, I want it to be easy for everyone to build. So I think, is that the one that, no, that's the one. I think that's the one that I have a bunch of that you can get on eBay pretty easily. Although that Amphenol, the RJHSE is another common one. The 5380, yeah, that's the one. Okay, so the 5380 does not have any LEDs. The 5381, 82, 83, etc., they have the LEDs, and then the actual digit there just specifies what colors the LEDs are. So for this one, we're going to go with the 5380. And I am not going to bother putting LCSC numbers on here, so just the outline. Okay, cool. And similarly, actually I should have done this before I copied it. Let's look for a footprint for this one. Oops, no. Connector audio. Nope. Oh, that's a good one. But that's the one that I have a bunch of, and I know you can get commonly on eBay. Yay, something good to watch. Well, I don't know about that, Steve. I mean, that's awfully generous. Let's put it that way. Okay, that's the one I want. The horizontal with the thing. Okay. Oh, wait. No, that's not it. Because the ends are the switch. I want that, but in through hole. The PJ320, that's the one. $320. There you go. Except, why do you have that extra one over there? All right, you know what? I think I may have made my own library for this then. Yeah, I did. That's why. Okay. So I've got my own library outline for that. Okay. Oh, hey, knock it off. There we go. the same thing here. This is not going to be a how do you use KiCad video. I'm just going to blow through a bunch of things that I would normally take the time to explain how I'm doing, but I'm not going to bother with that this time around. I've got enough other videos on that. I will, well, yes, but Kelvin says the extra pin is for holding it down to the board better. That is true, but none of the connectors that I have actually have that 5th pin. They've only got the 4 pins. So I was curious why that outline had that. So it must have been for a connector that I don't have. Okay. Actually, Steve, I already did drop it in the M17 Discord. I put it in the non-M17 share and tell. Is that the right spot for it? I figure what I'm doing is not technically M17. Should I throw it in the module 17? Oh, perfect, he says. Okay, cool. Very good. Okay, so first off, let us drop some grounds. I'm going to ground that shield. And I'm going to hard ground that one for headphones. And I'm going to hard ground these, all of these for microphone. No, nope, just kidding. Just kidding. Okay, let's do this instead. I'm going to create some references. Headphone left audio is there. Headphone right. And oops, nope. And curses. Come on. Headphone ground. Because they all have their separate grounds. Yep. Close. We're going to take the headphone left, run at the tip. We're going to take headphone right, put it on ring 1. Just kidding. Ring 1. And headphone ground and put it on ring 2. And then we're going to make a jumper for shield as to whether it's ground or whether it is microphone. So let's go ahead and drop that now. Jumper. 3 open solder jumper. 3 open. Nope. I don't want that to be bridged on the board, so I think I want the open one. Then check outlines. Jumper. Jumpers are going to be up here. Jumper. Yeah, those are all surface mount. Oh, we're talking about solder jumpers. Yeah, that's right. So because people are going to be assembling this, they're going to have to assemble this how they want. Yeah, Steve is amazing to hear M17 is on board. Very exciting. Thomas Martin says, Steve says, definitely looking forward to seeing it on the M17 board. Yeah, I am too. Y'all were... I thought you were going to be the first ones to adopt OHIS and natively onto a project, but it turns out somebody else did. Herb, G1 mumble. I don't remember your call sign, Herb. I apologize. He sent me a Mastodon message saying that he integrated OHIS into a project that he's working on. And it looks like that's already gone to manufacturing, which I thought was pretty darn rad. I don't like that symbol. It's too big. We are going to replace that with the solder jumper 3 open. There we go. Okay, there we go. So, that's going to put that there. What want to call that? Headphone or CTIA. Okay. So then we're going to take that and we'll put that there. Actually, and then mic, which we haven't put down yet. Okay, so mic plus goes here. Mic minus goes here, and we'll just finish this out. PTT and VCC, which we aren't going to be using in this. So I'm going to put that there, and then ground, like power ground. We'll put that there. Okay. Oh, yes, Herb Mumble. I know him, RJ says. Thank you, RJ. Second isn't bad, just shows more interest. Yeah, that's true. I am super excited that we have this many people who are putting this in their projects. So thank you. Nerd Garage found my Mastodon and said, Herb, G1LRO, Golf 1 Lima Romeo Oscar. Thank you very much for that, Nerd Garage. And thank you, Herb, for putting that on there. He didn't reach out to me and say, hey, can you help me with this or anything? It's just like, yeah, I like what you're doing, so I put it on my thing. Sweet! So I don't know if there's other stuff like that out there somewhere. I kind of hope there is, but I don't know for sure. So that's going to go there. That is also going to go on the tip of that. And mic minus is going to go on these other ones. So there's your microphone. Oh. Poope. You know what? I need to have another jumper here. Is it a three-way jumper? It is not. It's just a two-way jumper. Because if you are going to rig that up as a CTIA, then you need to bridge. You need to bridge power or headphone ground and microphone ground. So that one there and that one there. All right. Yeah. Is Herb the guy building the open source APRS data terminal? That sounds right, yes. He called it a USB radio modem, I think is what he called it. But it's a USB chip on one side it's a USB port on one side that has a USB sound interface and a USB serial port. And then it has a bunch of connectors on the other side to connect to the radios, like the 3.5 millimeter and 2.5 millimeter Kenwood standard hand mic connection, and a couple of other things as well. I don't know what his exact use case is, but it's APRS data terminal. That sounds about right, or at least it could be used for that. And then PTT. We'll go down here. You are power ground. Oops, I actually just figured out that I don't want to use mic plus on that stuff yet, because we do need to have an optional mic preamp in here. Okay, so I don't want mic plus there. Instead, oh shoot, this is all going to be backwards from the way my brain thinks about it. Okay, so HHIS.org. Let me bring up the web page, and then I'll bring it down onto the screen that y'all can see. In the Open Headset Interconnect Standard document, this is the actual standards document itself. It's available on OHIS.org. I'm putting parts under my face. What are you trying to say, Kelvin? I will fix that. Thank you very much. Dan Soul says that Herb has a Facebook post and video coming showing it doing APRS with a Baofeng. Cool. That's awesome. Did you already know about that, or did you go look for him after hearing me talk about it here, Dan? All right, so this is the OHIS document, and what I am looking for... What am I looking for? Darn it. Oh, yes. The mic preamp, which is going to be at the very end. There we go. So this is the schematic that I need to copy. And I realize that this is all probably a higher resolution on my screen than is what's getting streamed. So, sorry about that. But Dan says he saw it last night on a Facebook post. So you already knew about that coming in. Did he mention in that video that, or in that post, that he was using, that he was putting OHIS on it? Okay, sir, I need to copy that. Let's do this. Okay. This is all going to be turned around weird, unfortunately. Because in this schematic, the mic is on the left and the output is on the right. But the way I've drawn this over here, the output is on the left and the mic input is on the right. So we're just going to have to get creative with this, I think. All right. So C small. All right. Put that over here. Value 1 just kidding. 1 microfarads. And then a couple of resistors. 3 of them actually are small. 1 up there. Let's do this. Select an outline for this. I'm doing all of this with through hole, even though I hate through hole. But as a open source project, that's probably best. So I want a horizontal. Pin 7.6 millimeters. There we go. That's the one. Okay, I think that's a standard 1/4 watt without having to pinch it in there so much. All right, so now I can do that. Okay, so now 1 more of those down here and another one of those over here. Okay. Value, this one is 75K. Value, piss off. Come on. 27. Jiminy crickets, what is it with focus? And then, bloody hell. 470 ohm. Dan says that, yes, he did mention it on the stream. So that's cool. Herb, thank you so much. I think it is rad that you are putting OHS on your stuff. 3904. Yep, that'll work. So we just need some standard BJT here. It's not critical which one it is. It'll work with a 3904 or 2222 or S9013 is just what KiCad had, or not KiCad, JLC PCB had when I was designing this for surface mount stuff. Okay. And let's put a... Oops. Okay, I can do away with this. I know the rest of that. Okay, which means I can do that. Now, hopefully, all of my focus and stuff will be working better. And I am not underneath my face. Yay! Okay, so let's put an outline on this. Capacitor, through hole. It is, nope, it is not an axial. It is a radial. We're going to do a pin spacing of 2.5. Nope, it's not even a radial. It is a, 1 microfarad. those are going to be yeah, discs will do. Okay. But I want pin spacings of 2.5 or 5.0. Don't they have a part that was like work on either? I thought they did. No. Oh, they're there. But not radial. Or not cylindrical, rather. Huh. Okay. I thought so this is an outline that's designed to work with either 5mm spacing or 7.5mm spacings. And I thought they had something like that, but for 2.5mm and 5mm in the little disc capacitors like this. So maybe not. And you know what I'm going to do? I'm going to put both of them on here. Watch me fly. So that's a 2.5. Let's put a 5 in there as well. Okay. And then just put those suckers in parallel. Now you're only ever going to populate one of them, and that's okay. Actually, I think both of those are, yeah, these are mic minus. So I don't want ground on that. I want mic minus. I want mic ground on that. Oops. Okay. So, all right. So mic plus and mic minus are over here on the OHIS side. I'm going to make this, well, mic minus is the same. Mic plus 3.5. So that just signals that this is the mic plus signal from the 3.5mm. So I want that. That's our input. And then mic plus on the OHIS is our output. So what in the heck is all of this? So if, oh, I need to make this switchable. Jumpers. Solder jumpers. Solder jumper 3 open. Solder jumper 3 open. That's the one I want. Okay. If your microphone on your headset is an electret microphone, then it should work straight away with OHIS without requiring any adapters or adaptation or amplification or anything. But if your microphone is a dynamic, then you do need to have a microphone preamp. So it's actually covered here in the OHIS document. The two most common types of microphones used are dynamic and electret. Dynamics are about 20 dB quieter, and they do not need a bias voltage. In fact, if you run a bias voltage through them, they'll actually burn out. Electret microphones are about 20 dB louder, and they require this 5-volt bias voltage through a current limiting resistor on their input. So you need to put a DC voltage across the pin. So one of the things that I did, and the OHIS standard is the electret standard. So if you have an electric microphone, you can just connect it straight into the OHIS. If you have a dynamic microphone, you need something to give it that extra 20-ish dB of gain and to remove that DC bias voltage from the line before you send it into the microphone and burn it out. So what I did is I designed this small amplifier. It's 5 components, 3 resistors, a capacitor, and a transistor. And it uses the 5 volts bias voltage that comes over the microphone line to power the amplifier. The signal comes in from the dynamic microphone. This capacitor blocks all DC into that dynamic microphone. So the dynamic microphone's not getting any DC voltage that it shouldn't have. And then this amplifier gives it about, I think I calculated it out to be like 18 dB. It's close enough. And actually I have another design that is closer to like 27 dB if you end up having a quiet dynamic microphone and need something louder. Anyway, point being that you plug a dynamic microphone into this side of the circuit over here, and then plug this circuit into something expecting an electric microphone, and it works. It adapts a dynamic microphone to work in a circuit expecting an electric microphone, like Open Headset. And so I included that circuit as part of the standard so that it is open and free for anyone to use. I'm going one step further now and designing an entire adapter to include in the standard. So this open source adapter will be part of the standard and free and open for anyone to use, the entire thing, not just this one little part of the schematic. Okay, but I need to make it jumperable so that, or bypassable, excuse me, so that if you already have an electric microphone, you don't want it further amplified. You want to bypass this amp. So solder jumper, brain fart, dynamic amp bypass. Nope. Come on. Stupid selection. Okay. And we need another one of these, but flipped around that axis. Over here. Okay. Thanks for the nod on the contesting console PCB. Which, Mark, were you one of the Patreon folks that I put on there? Sorry, my brain is mush. I did a bunch of stuff all at once, and I don't remember the names that I put on. Yes, because I remember Mike Walker was one of them, and that the other name, there was alliteration there. So is that you, Mark? You're the one who I put on there? Thank you very much for being a patron. Oh, as an early adopter. Okay. Yes, I put that out there. That's actually on the Radio Pro. The early adopters are all on the Radio Pro list. Okay, so now we've got the jumpers that if you need to bypass this amp, you can jumper across the top 2 here, but if you need to put the amp in circuit, you put it on the bottom 2 here. And that will bypass that. These 2 capacitors here allow us to use either a 2.5 millimeter pin spacing or a 5 millimeter pin spacing. The resistors are all the same. The transistors are the same. We got our mic ground there, mic plus going into OHIS, mic plus 3.5 coming from the socket. That looks good to me. The only other thing that I want to do, button. Really? Switch, there we go. Push button. That's the one. And we'll put that here, and we'll put that there, and that over there, and then we'll take this and we'll edit this and make this one of these. I think the push buttons are down here. Nope, 6mm. There we are. And those are all referencing the heights. I think I want a 9.5-ish. We'll do that. So this is one of those very common buttons that let me find one. 6mm button. There. Like this. These are super common buttons that you can buy, 100 at a time. 6mm button. Let me bring that up on the search. And like 100 pieces. There we go. 100 pieces, 100 buttons for $4. Shipping included. Oh no, $3 shipping. So, here's one. 100 of them, $1.25 plus $3 in shipping. So $4.25. In a few weeks, you can have 100 of these buttons show up at your door, right? That's why we use these buttons, because they are dirt cheap. Okay. But that outline that I just chose is for that. And bring that back up to YouTube. There we go. I wish KiCad had a dark mode. I think it does. I know you can do various different color schemes, and I don't know whether they've got a dark mode color scheme. Schematic editor display options. Huh. Maybe not. Colors. KiCad default. Classic. Oh, that's even brighter. Well, you could make your own. Background is one of the colors you can change. So you could make your own dark mode. Yeah, the PC board starts out, by default as black. Someone just... What? Huh? Oh, got it. Sorry, my wife just texted me. She texted me the good news that the last of the HHI hardware just arrived. Ha ha ha. I already have all the Radio Pros and the User Pros are on my doorstep ready to be brought inside, so I'll do that after we're done here. Which means I can start shipping tomorrow. Then move the bypass label above these. Bypass label. Oh, I see what you're saying. Yeah, this is okay. This is just the schematic. The label will be far more important when it is when we're on the board itself. Okay. I think that's all I wanted to put on here for the open source one. Right? Do we need any LEDs? It's not easy to indicate a PTT because you don't know what they're pulled up to on the other side. That's defined by the radio. You would end up having to put a whole bunch more circuitry on there to buffer that and detect it, and then trigger an LED. I could put a power LED on there, but that seems a little silly as well. So let's just go with this for now. Let's see here. Does everything have RGB lights and a flashlight? No. CTIA. That one is a... Oh, I didn't put the jumpers on there. Okay. CTIA. That one is a solder jumper 2. Show me. Good. I'm glad Steve took my adamance of no in the proper vein. I don't want any of the bridged ones. So I think that's the one that I want. And then dynamic amp bypass, these are jumper 3s. Yeah, that one. Okay. So everything has an outline now because we went through and did that as we were going along. So I'm going to save my work so I don't lose it and then bring up the board. Okay. So the way I'm envisioning this is that I'm going to make... Oh, shoot. Okay. I may go back and make this all surface mount. All right, so let me tell you what's going through my mind. The way I was envisioning this is that I was going to make a two-board sandwich. So there are going to be two boards on top of each other. One of the boards was going to have all the connectors and all the electronics on it. And then Thomas Martin says make it both, and that's actually not a bad idea. Let me look into that in a second. The bottom board was going to have all of the components and all the connectors on it, and the top board was just going to be a case, right? Just a top panel. The labeling would be on there, and there would probably be a little cutout for the RJ45 so that it wouldn't be super thick. It would just be thick enough to kind of be flush with the top of the RJ45. And then there would be standoffs in the corners to hold the whole thing together. But then there would be nothing on the outside exposed. It would be two smooth surfaces on the top of the top panel and the bottom of the bottom panel, and you would have the RJ45 OHIS cable coming out one outside, and then the 3.5s coming out the other side, and then there would be the push button would stick out through the top board, so that you can use the entire adapter as a handheld PTT. As kind of like a rat in the snake, if you will, right? Like, so here's your headset cable, and, you would plug your headset into this side of the adapter right here, and then the OHIS cable into this, and this whole thing just becomes your handheld PTT with a little button that you can press on it. It's the same design that's in the User Pro, HHI User Pro. That's the way I have it. Have it configured there, but I wanted to do it here with just two boards instead of the whole Hammond case and all that fun stuff. Problem with doing it with through-hole is that now you've got those pokey bits sticking out through the bottom. So the tallest through-hole is the cap, maybe the transistor, and it's not so much the tall, because the tallest is going to be the RJ45. And so Thomas says it's only a problem if you don't trim well. No offense to the builders, but if you're using through-hole because you can't do surface mount, there's a good chance you're not going to be trimming these very well. That may be not a nice thing to say, but I suspect there's a strong correlation there. I did say RJ45. Sorry, Steve. You can throw me in modular connector prison next time. So I kind of like Thomas's idea of putting both surface mount. I'm not expecting people to assemble the surface mount themselves. If I were doing that, I would put 1206s on there. Well, maybe I will. But the other idea was to just put the JLC PCB part numbers in there, and let people just order it from JLC pre-assembled. I kind of like the idea of making this a build project, though, right? Like, that's one of the big advantages to this, is that it makes it a great DIY project. That's kind of one of the selling points to me, is that this would be a great DIY project. And if you just make it surface mount and orderable from JLC PCB, you just get boards and then you have to assemble it. You know what? I'm sticking with through-hole. Well, Thomas is saying this is a reference open source design, right? Don't make it a product. Yeah. I want to sell them, right? Dan Soul says you could use 3 boards like the Ham Radio Workbench Power Pull Distribution Kit. The boards are not expensive. The spacers between the boards are surprisingly expensive. So the fewer boards you have, the fewer spacers you need to put all of that stuff together. The spacers between those boards is a non-trivial part of the BOM cost for those power strips. I just went through the exercise of putting all that together and was surprised at how expensive those were. All right, so let's import everything from KiCad or from the schematic program, and hey, look, a bunch of stuff. All right. Which side is the front on that? Oh, shoot. I can't remember. The LEDs were down here at the bottom, so the top is the front side. Okay. So we'll put that over here. Oh, what do you think I am, European? Why do you not default to the one that I want you to default to? Sorry, Europeans. Totally not sorry at all. Okay. And let's throw down an edge cut. Oh. Okay. So, shoot. Hot glue spacers and duct tape wrap. That's just the way you would build it, Kelvin. I don't know, 4 inches by 1.5? That seems like it would fit in the hand. Yeah, keeping it to 4 inches is good from a cost perspective as well, because if you can keep it under 100 millimeters by 100 millimeters, then board fabrication becomes super cheap. You don't want it too short, though, because we still want it to fit in the hand. So I am going to go with for a full 4 inches. Okay. When it's holding in your hand, I'm trying to decide which end to put the button on. I've got it held in my hand. I think the OHIS cable is going to come out the bottom and the headset cable will come out the top. So the button for my thumb will be closer to the 3 millimeters. Okay. So I'm going to rotate this and put this up here somewhere. I don't know. That seems arbitrary. Okay. And then we are going to lay out our amplifier. Dynamic amp bypass. Which one is this? This one is... okay. Coming in from there. This one... Nope. Is coming in on that side. Wait a minute. Which side is ground on? Mic ground is up there. All right. So... All right, pin 1 and pin 2. Pin 1 goes to mic ground. Okay, so you rotate. And that goes through R3. So, actually, R2 goes from pin 2 also to mic ground. Okay. And then R1 footage acquired without missing any video. Show it somewhat linearly. Could heat shrink over the whole thing and cut a hole for the PTT? Yeah, a heat shrink would be another way of doing it. Yeah, we could get away with... Yeah. If you don't need the 3mm, the M3 holes for screws, we could end up making this a fair bit thinner. I worry about whether your heat shrink is going to be big enough to go over the whole thing. All right, capacitors. So, yep. Looks ugly, but it works. Okay. What is jumper 2? Ah. Yes. So we'll put this... shoot. Over here somewhere. Oh, yep. Actually, I can do this right here. Okay, cool. I know how that's going to work. You can get stupid size heat shrink. I mistakenly purchased some. Anyway, is big enough to go around my arm. Okay. Another option is the heat shrink they make for battery packs. Yeah. Although that ends up being pretty brittle when it's done, I think. And then headphones or CTIA. Yeah. So that's going to go here, I think. Yeah. Actually, that can go right there. Okay. All right. So I think I'm done with this for now. Plastidip. It's a lot bigger than it needs to be. So let's optimize a few things. I want to optimize this schematic. So first off, I think that'll be easier for those two, but then that one, you know what, forget it. Yeah, long and thin is definitely what I've got going on here, because that's going to fit in my hand better, right? So this is the shape of a User Pro. It's determined by the Hammond case, and then you've got the little button on top that is the push button. So OHIS on one side, 3.5 millimeters on the other, and the whole thing is just kind of a handheld PTT switch. But I figure this, and it could be a little bit longer. Where is it? There it is. It could be a little bit longer to fit in your hand a little bit better, but not as thick this way, and not as wide this way. It would also be kind of neat if all connections were on one end and the PTT was on the opposite end, similar to the ClearComm stage intercom belt pack. So you want it all on one side rather than kind of going out and back in? That's a question I'm going to put out to the audience. You'd rather have all the cables coming in and out one side? That would make it not super thin anymore. Okay, we got some disagreement. Although I can see it going both ways. Dancel says, agree on all one side. Kelvin says yes. Mark says easier to hold in the hand too. But Thomas says, I don't think so. I think I want it through. Thumb on the PTT, definitely. But the question is whether whether the cables come out the top. Your headset cable comes out the top, or whether the headset cable comes out the same side as the OHIS. Nerd Garage is indecisive and says, I think both ways have merits for both situations, different situations. I could, yeah. Unfortunately, I'm with Nerd Garage. I can kind of see both situations here. Putting all of this on one end, we don't have disagreement. We have multiple products. That's a fair point. But if we were to do that, actually, I would probably even do it like that, where the PTT would be opposite of the RJ45. So you would have OHIS here, your headset here, and then a separate PTT if you want. Yeah, all of this is going to be published, and people can remix this however they want. This is all Creative Commons attribution. It is not a complicated circuit. That is true. So I think I'm going to start it out this way and then leave it as an exercise to the reader to make it the way that they would rather have it. Kind of encourage people to start figuring this stuff out and building their own stuff, right? And that's part of what we're supposed to be doing here. I forgot something else. Let's put some mount holes on here. With a pad, please. Where are we? Ground. Oops. Edit. I want this to be an M3, please. Mounting hole. M3. But I want it with a pad. There we go. And import. Hey, look, a bunch of mounting holes. And we'll put these just a little bit behind. All right, so you're not going to go there. You are going to go there. That's going to make routing traces interesting. Maybe I'll go back a little bit farther. One, two, three. Okay. Okay. I think that's longer than it needs to be as well. Let's take a 1/2 inch off that. Oh, what the hell happened there? Oh. Oh, bloody hell. I hate the fact that that button is so close to the move button. Okay. Now that I can follow you what you've done here, I could always try to my hand a different PCB layout. Exactly. Mind you, I'd end up making the overkill version with a 4-pin XLR to deal with the headset, and that is something I would love to see people start doing. I have a headset with this unique connector. Go make your own interface. That's exactly, one of the things that I'm trying to encourage here. Now let's throw down some ground plane. Okay. Many fewer, actually not a whole lot of fewer connectors because ground is only used for a few things. Let's turn off copper pores. Oh, actually, turn that back on. Edit solid. Footprint. Nope, just kidding. Solid. What did I do over here? Shit. I edited the ground. That's what I did. Okay, nope. Everything else I want thermals except for these guys. Edit you. You I want solid. You not so solid. All right, Nishka. Okay, now we should have thermal reliefs on pins like that, but the screw holes are all solid grounds. Perfect. We've all heard Mark's adventures in overkill and product expansion. That is true. That was fun, but now I got to go work a bit. All right, take care. Thanks for hanging out, Kelvin. So, microphone down there, PTT down there. Okay. Let's set up our board. And net classes. We're going to default 0.015. Let's make some wider traces by default on here. I don't think I want 20s because I do still... Whoa! Why... the hell just happened there? Page board setup. Not clearance. What did you do? Three and a half. So that's still a thermal. Bloody hell. Board setup. Okay. 0.007. I mumble. 0.015. Track width is what I wanted at 1.5. There we go. Almost. Here we are. Clearance is 1.5. Yeah, Yeah. Thermal spoke width. Not too... We're going to do 0.25. Thermal relief gap, 0.015. I'm going to make that as the same as the clearance. Okay. Now, there we go. That's better. Okay. So I got some nice thick thermals to my ground pins, which are going to give some very good conductivity, but still preventing a lot of thermal conductivity, which will be good. And then those are solids. And okay, cool. So now I should be able to draw a pad from there to there. And then, you know what we do want? We do want a debouncing cap on that. That is worth... zoom out. It is worth putting a debouncing cap on this. So, 1 microfarad is probably a bit much. So we are going to have to add another bomb part to this. Actually, what are you doing? We'll do that there. 1 nanofarad is probably a lot closer to that. So what I'm doing here is I'm adding a capacitor to the PTT just to kind of shunt out any noise that it may pick up, and make it a smoother transition so that it moves around slower. The voltage around on it moves around slower, and doesn't bounce a whole bunch when you're in the transition between on and off. We want it to be a very clean transition one way or the other, and you can do that by throwing a little capacitor on there. And so we'll update the board, and that adds it to this. That's too tight. We'll put it over here. How reliable are those dirt cheap buttons? I've never had one fail, but I've also never tried to push one, 10,000 times in a row. So I don't know the answer to that question. Does that answer your question? Actually, no, I will do it this way. Okay. So I got the PTT going on the bottom trace there. So those are all mic plus, or pinion. Thomas asks how reliable those buttons are, and then I'm like, I don't know, does that answer your question? And I'm just like, I was just looking for an opinion, so sure. Okay. So we're going to move this down here, and then we'll, oh, you know what? Actually, let's group these together so I can treat them as a single grouping group. Okay. Yay, you're a single component now. Should I make those 0.1 header jumpers? My daughter's asking me to open a jar.
It's really tight.
It is really tight. Should those be 0.1 inch header jumpers so they're easier to change? I figure if we're doing through hole, we should probably go all the way. Jumpers, yes. Okay, fine. Oy. In that case, we're going to get you, and we are going to swap you out. 0.1 for the win. Easier to deal with. Okay, fine. Connector, pin headers, 2.54. 1x3 vertical. Yep. That one. And you are also a... I'm going to do this differently. So, 1, 2, 3, 4. I think odd even is the way they are usually done. Okay. So, if we do that and that, and then that and that. So now, if the jumpers are vertical, then the mic amp is in line. If the jumpers are horizontal, it's bypassed. I like that better. Dip switches. Dip switches aren't dual pole. I've thought about that, but yeah. Okay. So value. So yeah, horizontal is going to connect the 3.5 millimeter directly to the OHIS. This is shorted, but that doesn't matter because it's not energized. And then if you go vertical, the 3.5 millimeter will go into the input, and then the output will go into the... Yeah, that's perfect. Okay, so let's assign you a footprint. Pin header O2 by O2. 2 by O2 vertical. Yeah. I like that. All right. So in that case, I need to do the same thing here. I'm going to... Yeah. I'm going to do the same thing here. So 03, odd even. Okay. CT. Or CTIA. Okay. So, mic. Hey. And then, okay, so if that is, then, okay. Then headphone ground and mic ground. So if the two jumpers are on the bottom, then we're connecting the shield to mic plus. So the bottom position is going to be for CTIA. And if that's the case, we need to short the headphone ground and the mic ground. With the two in the top position, then the shield will be shorted to headphone ground. Okay, and just to make routing easier, I'll do that so that all three of these can just be shorted together. Okay, I think that's what I want there. Let's put an outline on this one. Pin header. Yes, I know. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, cool. Okay. I think that's cool. Now, update the board. Our jumpers go away, but we get new jumpers. Okay. Dynamic mic bypass. Okay, first off, let's bring this down here. Okay. So, okay. 3 and 4 are the connections to the amp. So that's assuming that it's up here. I think I want it the other way around. So I think I just want to swap 1 and 3 and 2 and 4. So if I just do, nope, that. There we go. There we go. Whoops. That's not mic plus. That's mic 3.5. Because that is... Yeah, glad I caught that. There we go. That's the input. Okay, so signal comes in here, there, into R2, and to pin 2. Here, let's just start laying out. .015. Okay, cool. Yeah. Pin 2 here goes up to there. Pin 2 here goes down like this. And into there. Pin 1 goes like that. And that's the mic ground. Oh! Why are you so small? Use net clasp. What in the hell? Actually, I think I want to do this differently. I think I want... because now my mic ground is down at the bottom. That's not fantastic, but it'll work. Now my mic grounds are down here. I still want to understand why that trace is so tiny. You're not setting it. 0015. Okay. I don't know why you weren't setting that. Okie dokie. Actually, I think I want the headphones to go around here. Okay, so let's route the headphones now. Oh, bloody hell. They are on this side. And PTT's on that side. Okay, fine. Yeah, okay. I want to keep it away from that screw terminal. Like that. 568A or B. Thankfully, it doesn't matter here. The only difference between 568A and 568B are the colors of the pairs inside the cable. It could be worse. You could have all 100 parts placed and routed, and your project manager decides to add another feature. I am my own project manager, and I've done that to myself. Not entirely proud of that, but I have, in fact, done that to myself. Okay. So... actually, I'm going to do that way, because the mic signals are up top there. Okay. All right. I'm going to lay out another ground plane, but for mic ground. Watch me do something silly. Priority to... Yeah, we'll do thermals on this. Could be using 25 pair cable. It's been a long time since I've used 25 pair cable, but I have done it. Oh, there it is. I used to maintain a network of serial terminals. I guess it's not a network at that point, but a bank of serial terminals at the library at my university. And I'm just going to do this for now. And we used 25 pair Cat 3, I guess, all over the library to run those terminals. It was a bit of a disaster. I don't want to say disaster, but it was definitely a lot of work. Oh, shite. I am not going to be able to get those headphones through there. No, we weren't even on Cisco 2511s. Those would have been modern by the standards. Yeah, Cisco 2511s came out in the mid-90s, if I remember correctly. This was it's not a mainframe, it was a mini computer. But it took 1, 2, 3, 4, I think 5 half-height rack, standard 19-inch rack spaces in our data center. Like 2 of them were storage. One was the CPU, one was a power supply. 2 of them were tape drives, one of them was a hard drive, one was the CPU. I don't remember the exact details, but it was a device. It was definitely a device. And yeah, we punched a lot of 66 blocks in that job. I actually got like RSI in my shoulder from punching so many 66 blocks in that job. When you're 18 and 19 getting RSI, that tells you something about your choices in life. Yeah, actually, I think I want to do this here instead. Oh, shoot. Nope, that's separate. Curses. Actually. That actually works out okay. All right, so what I'm trying to do is I'm trying to make a channel here for the mic plus to come down here. It's got to go onto this jumper block and then down into this area here, but I still need to make space for my headphone signals to come through. Steve says he used to throw a hammer. I assume you mean in the track and field sort of way? And that he therefore knows RSI well. No, this is only a 2-layer board. I'm not intending to go 4 with this. Throw a hammer is in construction. Yeah, Thomas asked whether this was going to 3-layer board. If you're worried about this PTT cutting off the ground underneath. I kind of am too. I'll put some vias on either side of that to connect that together. Actually, this may be... No, I do have it on both layers. This may be appropriate to only put on the top layer, actually. I think I'm going to do that. Okay. So ground underneath will remain solid. That, we'll do that, and I'll probably relay out that, lay that out a little bit differently. Will I be able to get that through there? Oh, even with that tiny trace, I can't. Oi. All right, so it's going to have to come out the backside. Yikes. Okay. Really don't want to be that close to that screw if I can avoid it. Yeah. Really? Okay. That's not what I was trying to do with that, but that'll get me there. Okay. I don't want to put that on the bottom, although I may have to, because that's going to be where you're touching it. That is a mic signal. Poop. Shoot. I don't really have any better options there, do I? Not a huge fan of that. Go around the end. The end of what? Oh, like out here and around and back in? I don't think I can fit... Oh, actually. I can go up through here. Hold on for 1 second. My builder is talking to me about what he's going to do tomorrow. Okay. On the red layer. Oh, nope, I got to go up this way. Because here I've actually got mic ground around me as well. So I can actually preserve my presence in mic ground for a good long while. Then the question is, can I sneak my way through there? And then clean that up a little bit. Really? Seriously? There we go. Okay, that's not so bad. No, no, because this is the size. Mark asks whether I can make the footprint of the mounting holes any smaller. No, because that is the size of an M3 screw head and an M3 nut. So you really don't want those to be any smaller. So actually, let me create a corner. Oh, shoot. Go back to my normal grid. Yeah. I can generally force the grid into doing what I want it to do. I have no idea whether this is going to work. We'll see what this looks like after I'm done dragging this around. Actually, I want that back there. Actually, we'll bring that down there. And one more. Like that. Okay. We'll re-pour our grounds. Well, look at that. Not what I wanted. So let's bring that down here. Mic minus. And did not quite accomplish what I wanted it to here either. I would have to expand that out big enough to put a via in here. Oh, that's interesting. That pour and that pour are isolated because this is only on the red side. So I'm going to do another one on the green side, and we'll do mic minus, yep. And we'll do it down here. Zip. Now, can I stick a via in here? Ooh, I can. Sweet. And we'll do another one there. All right. Okay. That is not the prettiest layout I've ever done, but it'll get the job done. Well, let's drop some more vias in here. Because this is all mic. Via all the things. Daniel says he's watching as he cleans his shack, a.k.a. guest room, for the mother-in-law to stay in. She arrives in 2 hours. Well, there we go. Honest question, is it via or V-Y-E? Via? Oh, via or versus via? Yeah, that would be probably a regional thing would be my guess. Via as in viaduct. So Nerd Garage says he's always heard it via. Daniel Wynn says he's always heard it via as in viaduct. Yeah, Nerd Garage just said the same thing I just did, that it's probably a regional thing. Honestly, I've never really thought that far ahead about it. I don't know. I don't have an opinion. Jason Kitchens pronounces it VIA. It's right up there with saying I pronounce it GIF. Trolls. I'm going to bring that out back here as well to connect it all the way around. Except on the ground. Oh, because that one needs to get... There we go. You need to get pulled out too. Okay, if you're not going to do that, then we'll just pull that all the way down. There we go. Daniel Wynn says he's trying to learn more about circuit board layout via, pun intended, osmosis. Very good. Hopefully we can deliver. Okay, you know what? Yeah, shoot. Damn it. Even that's too big. Okay. So the mic comes around from that pin, goes into the jumper. Then the jumper connects that into the mic 3.5, or it connects into the headphone ground. Okay. So let's put a via. Now you've got me saying via, darn you. A via all over the place. Via all the things. I hate you. Look what you've turned me into. Nope, not that one. Because that's a mic plus. I'm looking to via the grounds down. So that's a ground. Okay. That's also a ground. Via all the things. Do you think OHIS will have any traction outside the amateur space? That is a mighty fine question. I would certainly love to see it, but it's not my goal. My goal is for amateur, but I don't see a reason why it shouldn't be part of my goal. I don't know. That's a good question. Can you think of any other industries where that collection of signals makes sense? Right? Aviation does have has several standards, unfortunately, but they are standards. The other thing I could think of would be just like normal headsets, like PC gaming headsets, but they don't really need a PTT. So that and as soon as you take away the PTT, then the CTIA standard is plenty good enough, plenty sufficient. In fact, the CTIA standard is pretty much identical to OHIS at that point, with the exception of the keeping of separate grounds. OHIS keeps separate grounds for mic and headphones, whereas CTIA does not. But other than that, they are electrically identical. So I don't know that the headset industry would be really chomping at the bit to do anything, because they kind of already got theirs. Yeah, what else do you have? CB. Oh, damn it, those are all Mic Plus. I don't want to tie those. No, there's nothing. Shoot. Okay. You know what? Forget it. We're doing it. All right, we're doing this. We're going to put that on both layers. Okay. Draw that. And you've got the bottom layer cut in half by that. But that's why we have vias. Actually, remove that, remove that, remove that. Bring this back up there. Take this and that. Yeah. Those don't need to be separated because they are either the same signal or it's a ground. And in either case, I'm willing to shoot, I do want that. In either case, I'm willing to let it be right next to it. 1, 2, 3. Okay. And now that gives me spaces for vias. Okay. Okay, now I should be back on the bigger grid. Comms in the entertainment business. I'm dreaming up a way to integrate two-way radio traffic and a feed from in-ear monitors. Says Mark. This is referring to the question of, do I see OHIS getting traction anywhere else? It's definitely an interesting idea. It's an open standard. There's nothing stopping anyone from adopting it for whatever the heck they want. I don't know that I'm going to go out of my way to try and target that industry, but I would certainly work with anybody who wanted to build that into some hardware. Certainly. Do you have any input into any products that would be interested in something like that. And the feed from my 705 so I can hunt POTA during the show. Romeo, oh Romeo, wherefore out there CQ POTA? I see that going well. Via all the things. Okay. All right, so I got my power grounds up here with PTT. I've got my mic and mic grounds over there. I've got my headphones. Oh, shoot. Do I want to turn this into a headphone ground? This whole area over here. I kind of feel like I do. Huh. What do y'all think? Nope. There we go. Time for dinner. Thanks for this, Mark. I'm looking forward to making a few of these. Awesome. Well, thank you, Steve. Actually, M17, Wojciech, on that call that we had about Module 17, I can't remember whether you were on it or not. I'm horrible with call signs. Was like, are there open source versions of these things, or is this going to be open source? I think was his question. And I'm like, well, my product isn't open source, but there's nothing stopping somebody else from making an open source version of this. And then I'm like, well, shoot, why don't I do that? And so here I am making an open source version of it. Why don't I do that? Simple, because I sell these things. Why am I competing with myself? Why do I hate myself so much? I don't know. I don't actually hate myself, but it is an interesting discussion. Headphone ground. 3. Okay. I can't remember which of those is going to win. So we'll do that. We'll keep them separate. We'll just do this. Give me the via. There we go. Okay. All the grounds. Those are not ground. Not anymore. Go away. Ground, 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 ground. Okay. I'm looking forward to you wiring the 8-pin connector. I have a board I've mostly developed, but keep getting stuck on how to route the 8 lines out of the 8-pin. Yeah, you are not wrong. So Thomas pointed out that he ran into one of the hardest parts of OHIS, which is how do you get all the signals in and out of here? And I don't have a great answer, to be perfectly frank with you. So in this case, this one is ground. Stephen Wilson. Hey, Stephen. So this is power ground here. So I will probably keep power ground on the bottom layer. But headphone ground is going to come around this side and become a copper pour and take headphone right with it and headphone left. And so those three are going to, let me get rid of the VIA tool. So headphone ground, headphone left, and headphone right are going to come around here and go down. Mic plus and mic minus, they're going to have to just go weirdly, like this one around this side and this one come in here, and this one is going to have to come around this side and then go green, go on the bottom layer and come under the PTT, and then once the two of them are together here, then they can go straight across. So you'll notice that I've been intentionally kind of like keeping all the headphone stuff down on the bottom, keeping the microphone stuff in the middle, and the PTT stuff on the top. That's intentional, and I've been doing it specifically because of the orientation of this connector. Sure. Yeah, it's you have definitely hit the nail on the head of one of the bigger challenges. Now, if you don't care about keeping grounds separate, you'll notice that power ground, headphone ground, and mic ground are all right next to each other on the back side of the connector. That was not accidental. So that means that if you don't mind tying all those together, they can all just be tied into the pore, and then you've got all the signals on the front side, the side toward the board of where you would go. This is VCC. We're just not using it in this particular situation. It'd be easier if you didn't care. Yeah, that's true. Unfortunately, I do care. Unfortunately? Anyway, you get the idea. Nope, not that. We'll do it up here. Create corner, because I'm going to need more space for that. So we'll cut that off, and that'll let me come up through there. Okay. So you just make you straight, and you don't need to be so low to the ground anymore, or to the edge. One down. Okay, so that still gives me some headphone ground. All right, I am just realizing that I've got some obligations at 6 o'clock that I forgot that I had committed to earlier today. So I'm going to start wrapping up my stream here. We're not done. Got a lot more work I need to do here. I went to a 4-layer board almost exclusively after my first public project. Routing ground around 100 parts in a small board is just too much of a pain. That is true. I don't know whether it makes it easier or worse, but I've got 3 grounds to worry about here. You'll note that it's kind of cut into these different channels, right? This is my headphone ground down on the bottom. This is my mic ground with the mic preamp. Kind of goes through the middle and then kind of curls around here to this connector. And then up here is power ground and PTT. So, yeah. All right, we are not done. I will come back and do this on another stream. But I used to do these live streams of circuit layout, and I used to do them all the time. But once circuit board layout became my day job, like that was me giving away the commercial goods. So I stopped streaming the design work that I was doing. So I kind of missed doing it and having people looking over my shoulder and catching problems and asking questions and all that. It was good fun. So thank you very much, everybody, for coming out. Sure, just before the 8-pin connector that Thomas was waiting for. Anyway, so hopefully you saw my describe how I was going to route out of this, and hopefully that'll help you. There's going to be a little bit of VAing and jumpering from bottom to top layer and stuff like that. So anyway, I got to get moving. Thank you all so much for coming out and joining me. Let me save this. I will push this up to GitHub, and I will add the GitHub link to the description of this video if you guys want to come take a look at what it is that I'm doing. But yeah, anyways, got to wrap up. Thank you all so much, and I will catch up with you later. Be good humans.